Dear students, in this video I am going to discuss the model number 2, probabilistic model. Here single period model with uniform demand. Fine. And no setup cost model. So these are the assumptions. What are the assumptions? T is constant interval between orders. Z is the stock level at the beginning of each period of time T. Demand is uniform. Here the demand is uniform. Fine. This is the main difference over the period, and it is R units per period. That is, एक पीरियड में टोटल आर डिमांड है. सो पर यूनिट टाइम कितनी हुई डिमांड? आर बाई टी, बिकॉज पीरियड की जो लेंथ है वो टी है. सो आर बाई टी इज द पर यूनिट टाइम डिमांड. फाइन. पी आर इज द प्रोबेबिलिटी ऑफ रिक्वायरिंग आर यूनिट्स इन टाइम टी. दिस इज द प्रोबेबिलिटी दैट आर यूनिट्स इज रिक्वायर्ड, एंड सो दिस इज द प्रोबेबिलिटी. लीड टाइम इज जीरो. C1 is the holding cost per unit time. Shortages are allowed and backlogged, and C2 is the shortage cost per unit time. So these are the assumptions. Fine. So, and this is the model. So here again we are having two cases when Z is discrete and Z is continuous. So first we are taking Z is discrete case. So if demand is less than stock level, then we have this diagram. So here this is the stock level and demand is less than R. So this is the total demand. For example, in this period from 0 to T, demand is total R units. So per unit time demand is R by T. So this stock is R level. So after time T, stock will be Z minus R. क्योंकि R units की demand थी वो पूरी हो जाएगी, तो stock रह जाएगा Z minus R after time T. So we just join these two. So per unit time demand is R by T. Per unit time. After T1 time, R units finishes. So ultimately Z minus R is the remaining stock. Fine. So now based on this diagram, so holding cost will be C1 by 2. Holding cost is C1 into area of this triangle. Area of this figure. Fine. So what is the area? Z plus Z minus R by 2 into this distance T. So C1 by 2 Z plus Z minus R into T. This is the area. So after multiplying this, so we get C1 Z minus R by 2 T. So this is the holding cost. In this period there is no shortage, that's why shortage cost is 0. So the total expected cost, because the probability that you will fulfill all the requirement is PR. So the total expected cost is here from R from 0 to Z, because R is less than equal to Z here. So maximum you can fulfill Z amount. So that's why R is 0 to Z. C1 Z minus R by 2 T PR. This C1 Z minus R by 2 T and then multiply by this PR. This is equation number 1. Now the second, when demand is greater than stock level. So we have this diagram. So this total distance from here to here is T. Per unit time demand is R by T. But demand is greater than stock level. So obviously after some time this will finishes. कुछ समय बाद ये खत्म हो जाएगा. Suppose T1, after T1 time this will be finishes. So from T1 to T, that means this distance T minus T1, there is a shortage. There is a shortage. Fine. Now from the graph you can see that this distance, this from here to here, OA is Z, stock level. Fine. And R minus 2 is per unit time demand. So R by T multiply by this time T1, this is nothing but Z. So Z is equal to R by T into T1. This is the rate per unit time multiply by time T1. This will give you the stock level Z. So now so this figure says that we have holding cost as well as shortage cost. So now the holding cost is C1, area of this triangle, which is 1 by 2 Z into T1 multiply by C1. This is the holding cost. So C1 1 by 2 Z. Now T1 from here you can find out T1. T1 is Z T divided by R. So substitute it here. C1 Z square T by 2R. Now the shortage cost. Shortage cost is evaluated with the help of this triangle. So C2 area of this triangle, which is 1 by 2. This distance is R minus Z, because total demand is R, stock is Z. So the shortage is R minus Z. This is the shortage. ये shortage है R minus Z amount की. क्योंकि टोटल डिमांड R है, स्टॉक Z था, तो R minus Z is the shortage. So 1 by 2 Z R minus Z into this distance. This distance is t minus t1. T minus t1. Substitute the value of t1 from here. So we get this value. So this is the shortage cost. So the total expected cost in this situation is r is from z plus 1, because r is greater than z and discrete case है, तो obviously z plus 1 से start होगा. Z plus 1 to infinite, the holding cost plus shortage cost multiply by PR. Fine. So this is equation number 2. So now the total expected cost per unit time for this model is, this is from the, this from equation number 1, holding cost plus from r, from equation number 2, r from z plus 1 to infinite, this cost, holding plus setup cost, holding plus shortage cost. So this is the total cost. Fine. Now for the minimum, we know that for minimum value of Cz, according to the minimum criteria, delta Cz minus 1 is less than 0 is less than delta Cz. Fine. So now first find out the value of delta Cz. This. So delta Cz is nothing but Cz plus 1 minus Cz. But we know that what is Cz. So just replace z by z plus 1 here and then take the difference of with Cz. So what we will get? So Cz plus 1 will be this. This is Cz plus 1. Just replace z by z plus 1. So this is Cz plus 1 minus Cz. This is minus Cz. So now just summarize these two. Assemble these two, because they are similar to each other. So take r from 0 to z. So this minus this, we get this, plus because here we have taken only z, so this एक टर्म बच गया यहाँ पर r इक्वल टू z प्लस 1, तो इसमें वैल्यू पुट किया, तो दिस विल बी दैट टर्म c1 z प्लस 1 माइनस z प्लस 1 डिवाइडेड बाय 2 pz प्लस 1. फाइन. नाउ सिमिलरली असेंबल दीज टू. तो इन दोनों में जो मिनिमम है वो ये है. सो r फ्रॉम z प्लस 1 टू इनफाइनाइट, दोनों को समराइज किया तो दोनों को यहाँ पी आर इज कॉमन लिया तो ये है. बट एक टर्म छूट गया है यहाँ, हमने एक टर्म एक्स्ट्रा लिया है यहाँ. वी हैव स्टार्टेड विद z प्लस 1, तो एक टर्म हमें सब्ट्रैक्ट करना पड़ेगा माइनस कौन सा टर्म, फॉर z प्लस 1. तो जस्ट पुट r इक्वल टू z प्लस 1 हियर एंड माइनस सब्ट्रैक्ट. सो माइनस 1/2 z प्लस 1 c1 z प्लस 1 होल स्क्वायर प्लस c2 z प्लस 1 माइनस z माइनस 1 होल स्क्वायर pz प्लस 1. तो एक टर्म हमने क्योंकि यहाँ ऐड किया है तो हमें सब्ट्रैक्ट करना पड़ेगा. फाइन. सो आफ्टर सिंप्लीफिकेशन वी गेट दिस. सो दिस इज कैंसिल आउट विद दिस. So ultimately after assembling all this summarization, you just see simple calculation. So we get this term. So C1 R from 0 to Z PR, that means this, plus C1 plus C2 R from Z plus 1 to infinite 2Z plus 1 by 2R PR minus C2 summation Z plus 1 to infinite PR. Fine. So this is as it is, this is as it is. Here is a change. C2 is, this can be rewritten as further r from 0 to infinite pr minus 0 to z pr. तो इन 0 to infinite में से जब r from 0 to z को सब्ट्रैक्ट करेंगे तो यही बचेगा. फाइन. बट वी नो दैट this the value of this is 1 because this is the probability. So total sum will be, probability will be 1. So बाकी टर्म एज इट इज है, ये एज इट है, ये एज इट इज है. हियर C2 this is 1 minus summation of this. Fine. So now we will assemble these two, first and last term. So summation C1 plus C2 summation R from 0 to Z PR plus C1 plus C2, this summation PR by 2 minus C2. Fine. So now take C1 plus C2 common, so we get this quantity. This is nothing but delta CZ. Similarly डेल्टा सी जेड माइनस 1, क्या करेंगे हम, जेड की जगह जेड माइनस 1 कर देंगे. तो C1 प्लस C2 समेशन फ्रॉम 0 टू जेड माइनस पी आर प्लस यहाँ पे करेंगे तो वी विल गेट जेड माइनस हाफ आर फ्रॉम जेड टू इनफाइनाइट पी आर बाय माइनस C2. सो दिस इज इक्वेशन नंबर 6. नाउ वी विल यूज 5th and 6th टू गेट द मिनिमम, बिकॉज मिनिमम इज दिस. तो इसमें पुट करेंगे. सो व्हाट वी विल गेट दिस इनइक्वालिटी. सो नाउ डिवाइड बाय C1 प्लस C2, बोथ साइड्स वी आर हैविंग C1 प्लस C2. सो फर्स्ट ऐड C2 हियर. सो जैसे C2 ऐड करेंगे तो C2 मिडल में आ जाएगा हियर इन प्लेस ऑफ 0 एंड देन डिवाइड बाय C1 प्लस C2. सो वी गेट दिस इन इक्वेशन. सो दिस इनइक्वालिटी इज बेसिकली द रिजल्ट टू गेट द ऑप्टिमम सॉल्यूशन. फाइन. नाउ Second part is the continuous case. Fine. So in continuous case, in place of summation, we are having the integral. So first equation is, this is the total cost. If you will see, this was the total cost function. This was our cost function. Equation number 3. So in place of summation, we have integral 0 to z c1 z minus r. pr की जगह हो जाएगा fr. fr is our probability density function. Fine. So fr dr plus, here in place of z plus 1, for maintaining the continuity, r is z to infinite 1 over 2r c1 z square plus c2 r minus z whole square fr dr. So this is our. So now for the minimum cost, dc by dz should be 0. So d by dz cz plus is equal to c1 d by dz integral 0 to z this plus d by dz of this. Now we have to apply the principle. So here this will be c1 0 to z. This will be, when this integral goes inside the integral, this will be the partial derivative. So partial del by del z, z minus r by 2 fr dr, plus now substitute the upper limit, c1 z minus r is z, z by 2 f of z, and then dz by z, minus substitute the lower limit which is 0. So z minus 0 by 2 f of 0 d0 by dz, d0 by dz will be 0, that's why 0. Similarly for the next part, so we get this. So after assembling this and simplification, here we get this dz by dc is equal to this. Fine. So for the minimum cost, we get dc by dz is equal to 0, which is c1 plus c2 is r from 0 to z f of r dr plus c1 plus c2 z to infinite z by r fr dr minus c2 is equal to 0. So take this c2 in the right hand side and then divide by c1 plus c2, so we get this. Fine. So basically we have to differentiate this. Fine. And then taking the simple calculation. Fine. So after this we get this result. So this is actually the equation which is used to find out the solution. Fine. And then if you wish to find out the second derivative, then again you have to differentiate this, again apply the same principle. So this, after simplification, we get positive value. Fine. So this shows that we are getting the minimum cost. So this is the model, and in the next video we will take example how to apply this approach. Fine. So thank you.